Ever wondered how a snake without limbs, ears, or eyelids becomes one of the most efficient hunters in the animal kingdom? Snakes are truly unique creatures, possessing a suite of extraordinary skills that make them the epitome of evolutionary adaptation. They've been around for over 100 million years, and in that time, they've diversified into over 3,000 species, each with its own unique set of hunting strategies. From the lightning-fast strikes of the rattlesnake to the stealthy underwater ambush of the sea snake, these predators employ a variety of techniques to secure their next meal. Some snakes use their highly sensitive tongue to pick up the scent of their prey, while others rely on their keen eyesight or heat-sensing capabilities. Regardless of the method, these serpents are masters of their craft, each playing a vital role in their respective ecosystems. So, buckle up and get ready to dive deep into the fascinating world of snakes and uncover the secrets of their hunting prowess. One might question, how does a snake, seemingly handicapped by its lack of conventional senses, detect its prey? This fascinating question leads us into the intriguing world of snake sensory perception. Snakes have evolved unique sensory systems that, in many ways, surpass our own. While they may lack the sharp vision or hearing that we humans rely on, they make up for it with an extraordinary sensitivity to vibrations and thermal changes. They also have a highly specialized organ that humans simply don't possess: the Jacobson's organ, also known as the vomeronasal organ. The Jacobson's organ is a crucial part of a snake's sensory arsenal. It's located in the roof of the mouth and is not used for tasting food like our own taste buds. Instead, it's a chemical sensor, incredibly sensitive to the molecules floating in the air. When a snake flicks its tongue out, it's not being rude or threatening, but rather, it's sampling the microscopic chemical composition of its environment. The forked tongue collects tiny particles from the air, the ground, or perhaps from the trail of a passing creature. When the tongue is retracted back into the mouth, these particles are delivered to the waiting Jacobson's organ. This organ then sends signals to the brain, providing the snake with a detailed chemical map of its surroundings. Think of it as the snake's version of smell-taste, a sensory perception we can barely imagine. Now combine this with their ability to sense vibrations through their jawbones, and you start to see just how attuned snakes are to their environment. A rustle in the undergrowth, the faintest of tremors through the ground, or the chemical trail of a mouse, can all alert a snake to the presence of potential prey. So, while we might initially think of snakes as sensory deprived, the truth is far from it. They have a whole different set of sensory tools, perfectly adapted to their hunting lifestyle. Their world is full of chemical trails and vibrations, a world that is largely invisible and silent to us. So, it's not about what snakes lack, but more about the unique senses they possess. Did you know that some snakes can detect their prey's body heat? Yes, indeed. This unique ability is made possible by a specialized organ known as the pit organ. Pit organs are infrared sensing systems that some species of snakes possess. These extraordinary organs are located between the eyes and nostrils on the snake's face. To understand how this works, imagine this. It's pitch black in the dead of the night. Most creatures would be at a disadvantage, but not the pit viper or the python. These snakes have a secret weapon: their pit organs. These organs can detect even the slightest variation in temperature, thus allowing the snake to see its prey in complete darkness. So, how exactly does this work? Each pit organ is essentially a tiny hole lined with a thin membrane. This membrane is packed with highly sensitive cells that can detect changes in temperature as small as a fraction of a degree. When a warm-blooded creature, like a mouse or a bird, passes by, the heat they emit warms up the membrane in the pit organ. This heat change triggers an electrical signal, which is then sent to the snake's brain. The brain interprets this signal as an image, allowing the snake to determine the location, size, and even the speed of its prey. It's like having built-in night vision goggles that work on heat instead of light. This is a truly remarkable adaptation that gives these snakes a significant edge in their environment. Now you might be wondering, why do only some snakes have this ability? Well, it's largely a matter of evolution. Snakes that hunt at night or in dark places have evolved this heat detection system to help them locate their prey. It's a perfect example of how animals adapt to their surroundings to increase their chances of survival. This extraordinary heat detection system makes these snakes formidable nocturnal hunters. It's a fascinating glimpse into the complex and intriguing world of snakes, showing us once again that there's always more to learn about these remarkable creatures. Once a snake detects its prey, how does it ensure a successful hunt? This is where the art of the deadly strike comes into play. You see, snakes have developed an array of techniques to catch and subdue their prey, each one as fascinating as the next. The method they use largely depends on the species, but it generally falls into one of two categories: venom or constriction. Let's start with venomous snakes. These creatures are equipped with specialized teeth, known as fangs, which they use to inject venom into their prey. The venom, a cocktail of toxins, works quickly to immobilize or kill the prey. The exact composition of the venom varies between species and can have different effects. Some venoms are neurotoxic, affecting the nervous system and causing paralysis. Others are hemotoxic, disrupting blood clotting and causing catastrophic internal bleeding. Regardless of the type, the result is the same. The venom incapacitates the prey, making it easy for the snake to swallow it whole. On the other hand, we have the constrictors. These snakes, which include species like the boa and the python, use a different but equally effective technique. They seize their prey in their jaws and then swiftly wrap their bodies around it in a tight coil. They squeeze with such force that the prey is unable to breathe, leading to suffocation. Contrary to popular belief, constrictors do not crush or break the bones of their prey. They simply squeeze tightly enough to stop the prey's breathing and circulation. Once the prey is lifeless, the constrictor will uncoil and swallow it whole. Regardless of the method used, the strike of a snake is a marvel to behold. It's an impressive display of precision, speed, and efficiency. Each strike is carefully calculated, ensuring that the snake expends the least amount of energy for the maximum return. Whether through venom or constriction, a snake's strike is a marvel of precision and speed. So next time you think about snakes, remember they are not just mindless predators, but skilled hunters with techniques honed over millions of years of evolution. So, we've learned that snakes, despite their unique challenges, are incredibly adept hunters. Let's take a moment to reflect on the fascinating journey we've embarked on together, exploring the intriguing world of these remarkable creatures. We began by delving into the unique sensory adaptations of snakes. Unlike other predators that rely predominantly on their sight or hearing, snakes possess a set of specialized tools that provide them with a distinct hunting advantage. Their forked tongues, for instance, are not just an intimidating sight, but a sophisticated sensory organ. By flicking their tongues in and out, snakes gather tiny particles from the environment. These particles are then analyzed by the Jacobson's organ, a specialized sensory structure in the roof of their mouth, providing the snake with crucial information about their surroundings and potential prey. Next, we journeyed into the fascinating world of infrared detection, a unique ability that is not commonly found in the animal kingdom. Certain species of snakes, particularly pit vipers, pythons, and some boas, have evolved a remarkable heat detection system. This system comprises a set of pit organs located between the eye and nostril on either side of the snake's head. These organs can detect even the slightest temperature changes, allowing these species to locate warm-blooded prey even in complete darkness. This makes them efficient predators, capable of hunting in a variety of environments and conditions. We then explored the deadly and precise hunting techniques of snakes. From the lightning-fast strike of the rattlesnake to the patient constriction of the boa, each snake species has a unique way of dispatching its prey. What all these methods have in common, though, is their effectiveness. A snake's strike is not a random act but a calculated move, aimed at incapacitating their prey as quickly and efficiently as possible. Throughout our exploration, we've seen how these unique adaptations have allowed snakes to survive and thrive in a variety of habitats around the world. From the hot, arid deserts to the dense, humid rainforests, snakes have evolved to become masters of their environments. They are not just simple, slithering reptiles, but complex and sophisticated creatures, perfectly adapted to their roles as predators. In conclusion, the world of snakes is a testament to the power of evolution and adaptation. Their unique sensory systems, heat detection capabilities, and efficient hunting techniques make them one of the most successful predators on the planet. The next time you think about a snake, remember, it's not just a slithering reptile, but a master of adaptation and an efficient predator in the animal kingdom. So, let's marvel at the intricate and fascinating world of snakes, and respect these incredible creatures for the skilled hunters that they truly are.